Okay, so we are going to continue from where we stopped. And last we were looking at what production theory. And with production theory, we're focusing on the maximizing our output, okay, with regards to giving our various what production inputs. And we're saying the production inputs literally are what capital and then and labor, capital and labor. Today we are going to continue from where we stopped. Last week we talked about issues on the marginal the rate of technical substitution. Today, we are going to take the class a little bit further by looking at firms' desire to maximize output, but they are actually constrained by certain things. Okay, so our today's topic is going to be on optimization problems, optimization problems. Now, under optimization problems, we are looking at the first aim, okay, of a firm is to do what? A firm's major aim is to do what? Is to maximize their production. Is to maximize production. Is to maximize production. And by maximizing production, we are talking about what? Maximizing output. We are talking about maximizing output. We are talking about maximizing output, which means that a firm's sole aim, okay, is to make sure they maximize Q, which is output. But you can only maximize output, okay, when you can only maximize output when you combine the two factors of production, which are what? Capital and labor. So to be able to produce Q as the production, you would need to have what? Capital and then labor. Because capital and labor are the things that, or the inputs that you will use to produce what? To produce your output. Now, we are talking about optimization, and optimization is basically looking at what? To maximize something or to minimize what? Something. Now, by optimization, our focus is on either to maximize something, okay, or to minimize something. And then what do we tend to maximize as what? As a firm. You know for sure a firm's major aim is to maximize what? Output. Another thing a firm would want to maximize is to what? Is to maximize what? Revenue, okay? Is to maximize revenue. Something that a firm also wants to maximize is to maximize what? Profit, to maximize profit. At the individual level, something that you also want to maximize as an individual, maybe when you are looking at consumer theory, is to maximize your what? Your utility. Is to maximize the utility that you will derive from consuming a particular commodity. Okay. And there are certain things that you will also want to minimize as what? As a firm or as an individual. One, as a firm, you would want to minimize your cost. You would want to minimize your cost as a firm. You would also want to minimize your what? Your losses. You would also want to minimize your losses and the rest. Now, optimization is simply talking about what? Maximizing something, and these are the things that you would be able to maximize as a firm, or minimizing something, and these are the things that you would be minimizing. So in economics, once you hear optimize, okay, it's either you maximize, you tend to aim to yield the maximum values of a certain unit, either output as we've seen here, or revenue or profit or utility, or you minimize what? Something, and things that you minimize are what? The cost and then the what? The losses. So if I give you a question and the question is about production and I ask you to optimize it, it simply means to do what? To maximize it. If it is a cost function and I ask you to optimize it, it simply means for you to do what? To minimize it. So later I'll be talking about this. So now let's look at the output side. Now you would know that a firm's production, okay, is dependent on capital and then what? Labor. It's dependent on capital and labor. But you will realize that the amount that you will spend, okay, or the quantities that you will produce as your output depends on the cost of this production input. Because you would have to pay for what? For capital. You would also have to pay for what? For labor. You will have to pay for capital, and you also have to pay what? For labor. So which means that you need to have a budget that you will be spending on what? On input cost. You need to have a budget that you'll be spending on what? On input cost. Because you would have to have what? Money that you will pay for price of what? For price of capital. And you would also have to budget for what? The amount that you will pay on price of what? On price of labor. Now, the price of capital, we will refer to it as what? As PK. And price of labor, we will refer to it as what? As PL. So what will be the budget for this particular, case? Remember, you would have to combine what? Capital and then labor to produce what? Output. But to combine capital and labor, you need to spend certain amount of money to produce, to acquire capital. And you also need to spend certain amount of money to acquire what? To acquire labor. So which means that to be able to produce, you need to have what is called a budget, okay? You need to have a budget for the input cost, the budget for the input cost, the budget for the input cost. In this case, the quantities of capital is referred to as what? K, and the quantity or the amount of labor is referred to as what? L. So the price of capital will be what? PK, and the price of labor will be what? Would be PL. So what will be the total cost that you will be spending on what? On capital. And what will be the total cost that you will be spending on what? On labor. The cost that you will be spending on capital, okay? So the cost on capital. So cost on capital, cost you will be spending on capital, okay, which is K, will be what? The price of what? Capital times the number of capital that you are employing, times the number of capital that you are employing. And the second one would be what? The cost that you are going to spend on what? On labor. The cost that you are going to spend on labor. The cost that you are going to spend on labor. And the cost that you'll be spending on labor, remember, is the price of labor times how many labor that you are looking at. So which means that your entire budget, okay, your entire budget, which means that your entire budget, okay, that you are budgeting or allocating, the entire budget that you are allocating for this, okay?
Look, our screen is off, so we are working on it.
Okay, so I should hold on.
Yes, please hold on. It's off.
Is it back?
Not yet.
Is it back?
It's not back yet.
Okay, thank you. So it's still not back.
Yeah, so I suggest those online, those physical should use their phones and join
Yeah,
so that you can proceed.
yeah,
Because
you can
it's
use
the
your
session.
phone to proceed whilst they work on it. I don't know who is working on it.
Yeah, so you please continue, Prof. I'll speak it.
Okay, good. So we have the budget for the production inputs, and the total budget that you will have, okay, will be what? The amount that you are spending on capital plus the amount that you are spending on labor. Okay. So in this case, we can let maybe our budget represent M. So M will be the budget. M will be the budget. So please note that you want to maximize your output, but you are subject to a budget or constraint. You are subject to a budget constraint, which means your total amount of production, okay, will be contingent on the what? On the budget. Will be contingent on the budget. So in this case, your budget constraint, in this case, your budget constraint function. In this case, your budget constraint function would be what? Would be the M, which is the budget, is equal to this one's, which is price of what? K times quantities of K plus price of what? Labor times quantity of labor. So this is your budget constraint function. This is your budget constraint function, where M is the amount that you have, that you would want to spend on these inputs. So M here represents the amount that you have. It represents the amount you have to do what? To spend on the what? On the production inputs. On the production inputs, where M represents the amount that you have to spend on the what? On the production inputs. So if you have maybe say 500 cedis that you have budgeted to spend on production inputs, your budget constraint would be what? This 500,000, which is the M that you have to distribute to know how much you will be spending on what? Capital, and how much you would be spending on what? On labor. So please note the budget constraint function is your total what? Income or budget that you have to spend on inputs, okay, which is M, is equal to what? The cost of what? Capital, and this will be the cost of what? Labor. So in this case here would be the cost. Here would be the cost. This is the cost on what? On capital, which is the K. And this one would be the what? Would be the cost on labor, would be the cost on labor. So this is the total amount that you are spending on what? Labor, and this is the total amount that you are spending on what? On capital, given the total what? Income that you have, or given the total what? Budget. So if I ask you, give you a question and then ask you to write or to produce the budget constraint function, please note the budget constraint function is what? The amount that you will have is equal to what? The price of capital times capital plus the price of labor times what? Times labor. So now, having known this budget constraint function, you have what is called the what? The production function. So we have the production function. We have the production function, and our production function is given as what? Q is equal to, let's say, FKL. And we now have our what? Our budget constraints. And we now have our budget constraint function. We now have our budget constraint function. And our budget constraint function is given as what? M is equal to price of what? Capital times capital plus P, price of labor times what? Times labor. So in this particular case, a firm wants to maximize. The aim of a firm is to do what? Is to maximize what? Output. Is to maximize output. But the firm is constrained by what? By the budget. So a firm's aim is to maximize output, but you are constrained by what? Budget. So if your aim is to maximize what? Output, okay, subject. So a firm is aiming at maximizing output subject to a budget constraint. Subject to a budget constraint. Subject to a budget constraint. In this particular case, how will the firm combine the two inputs, which is what? Capital and labor, to be able to maximize what? Output, given the budget? So a big question is, how will the firm, okay, maximize output? How will the firm maximize output? How will the firm maximize output? Subject to what? Subject to a budget constraint. Subject to a budget constraint. Subject to a budget constraint. So that is the big question. How will you as a firm maximize your output? Subject to a budget what constraint? Because a firm is always constrained by what? By budget. But they have the overall aim of what? Maximizing output. So how will they be able to do what? To maximize output, okay, subject to the budget constraint. Even at the individual level, how will you be able to maximize your utility subject to your budget constraint? Because as a person, you are limited by what? By income. So how are you able to maximize your utility subject to what? To your budget constraint. A firm is also talking about what? How they are able to what? To maximize profit subject to the what? Subject to budget constraint. Okay. At the same time, a firm is also aiming at what? Maximizing minimizing what? Cost. Remember, minimizing cost subject to the production, because you would want to minimize your cost, but you have some production quotas to meet. So how will you be able to minimize the cost and at the same time maximize subject to the production quotas or meet the production quotas that you would want? Now, to answer this particular question, you will need to use what is called a constraint. We have what is called a constraint problem. So in this case, we are talking about what? Remember, you want to maximize output, but you are constrained by what? By budget. You want to maximize revenue, but you are also constrained by what? By maybe say cost. You also want to minimize your cost, but you are also constrained by what? By production quotas. In this particular case, under the optimization problem that we are looking at, we are talking about what? Constraint optimization. We are talking about what? Constraint optimization. We are talking about constraint what? Optimization. Which means that you have what? Two things. One is the function that you want to maximize, which is production function. And then there's also another one, which is what? The budget constraint function. So to solve this particular problem involves what is called the constraint optimization what? Problem. And to solve the constraint optimization problem, one way that we will need to use is to use an approach called the what? Called the Lagrangian multiplier. So to solve optimization problems, okay, to solve optimization problems, you use what is called the Lagrange multiplier. You use what is called the Lagrange multiplier. You use what is called the Lagrange multiplier. So how is this Lagrange multiplier set up? The Lagrange multiplier is set up in a way that you will be able to use it to solve constraint optimization what? Problem. You will use it to solve constraint optimization what? Problem. You use it to solve constraint optimization what? Problem. Now, under the Lagrangian multiplier, you have two functions. Please note, you have two functions. One function is called the what? It's called the objective function. One function is called the objective function. And what is the objective function? The objective function is the function that you aim to do what? To maximize. And what do you aim to maximize? Output. Is that not it? Revenue, profit, or utility. So the objective function is talking about a function that you aim to maximize or to minimize. To maximize or to minimize. That is the objective function. In this particular case, our objective function will be the what? The production what? Would be the production you want to maximize or minimize. So in this case, our objective function is the what? Is the production function. So our objective function is the production function, which we have as what? Q is equal to F, K, L. This is the production function. So we will want to maximize production function. And this production function is now our what? Our objective function. The second one that we are also looking at under Lagrangian multiplier is to look at what? Is to look at the constraint function, is to look at the constraint function or the budget constraint function. You can say the budget constraint function, the budget constraint function, the budget constraint function, the budget constraint function. And the budget constraint function, remember we already have that. We said it is what? M is equal to PK, K plus what? PL, L. So for a Lagrangian multiplier to be used to solve the constraint optimization problem, you need to identify two functions. One, you need to identify which one among the functions, which ones among the function is the what? Is the objective function, and which one among the function is the what? Is the constrained what? Function. And it is very clear that we have the budget as the constraint function, and we have the function that we want to maximize or minimize as the what? As the objective what? Function. As the objective function. As the objective what? Function. Now, how do we set up the Lagrangian multiplier? How do we set up the Lagrangian multiplier? Okay, how do we set up the Lagrangian multiplier? Setting up the Lagrangian multiplier. Setting up. Is the screen back? Okay. So to set up the Lagrangian multiplier, it involves, or to solve this, it involves some few steps. Okay, just three. It involves some three steps. It involves some three steps. Now, the first step, okay, the first step involves the setting up of the Lagrange function. The first step, okay, so step one. Step one involves what? Set up. You need to set up the Lagrange. You need to set up the Lagrange function. And how do you set up the Lagrangian function? You set it up by what? By combining both your objective function, by combining both your objective function, both your objective and your budget constraint function, and your budget constraint function, and the budget constraint function, and the budget constraint function, which means that you need to bring the two together. You need to bring the what? The two together. You need to bring the two together, which is the what? The objective function. That is the function that you want to maximize or minimize. Okay. And then bring the budget constraint function as well. So let's proceed. How do we do this? The first setup. And the first setup. So assuming we have, let's say, the what is the name? The production what function that we've been looking at. In this case, we have this as the production function, and we have this as the what? As the budget constraint, as the budget constraint. So in this particular case, you will realize that the Lagrangian multiplier represented by maybe Gene. Okay, the Lagrangian multiplier, which we will represent by Gene, and what are the unknown functions? We need to find the value for what? For K. We also need to find the value for L. And then we need to find the value for the Lagrangian multiplier itself. So how do we do it? We combine the what? The objective function. And the objective function is given as what? This one. Okay, we are setting up the Lagrangian multiplier, or the first step, the Lagrangian function. Plus, please note that our budget constraint function that we have here, is the same thing as what? M minus PKK minus what? PLL, which will give us what? 0. Which will give us 0. That is when you subtract all the costs on what? Each input, capital and labor, from the what? From the budget, it should be equal to what? 0. So the Lagrangian multiplier function is given as this plus. So here is the Lagrangian multiplier. Later you will get to understand it better. Okay, so we will have what? The budget constraint function. We will have the budget constraint function, K minus what? PL. So this is the first step. So what we have done here is the Lagrangian function. What we have done here is the Lagrangian function. This is the Lagrangian function. This is the Lagrange. Is the Lagrange. People say multiplier, or you can say function. So that is the first step. So the first step is for you to set up the Lagrange function by combining the what, as you can see, by combining the objective function, which is the production, and the constraint function, which is the what? The budget. Okay. So the second step will involve what? Step 2. The second step will involve you as a firm to do what? To take the partial, okay? To take the partial, let's go quite technical, to take the first order. And we did this last week. To take the first order partial, derivative. To take the first order partial derivative and then do what? And set the results. And set the results to stationary. And set the result to stationary. What does this mean? The step 2 means. What does the step 2 means? It means that based on the first step, which is the Lagrangian multiplier, we are going to take the first order partial derivative, which means that we are going to differentiate this with respect to each production input, or with respect to what? The 3 unknowns. And what are the 3 unknowns? We don't know capital, we don't know what? Labor, and we don't know the Lagrange what? Multiplier. Okay, so we are going to differentiate this one with respect to each of the 3 unknowns and set the results to stationary. And by setting the result to stationary means what? Equating the answer to 0. Equating the answer to 0. So now when you look at the first one, the step 2, from step 2, we have the Lagrangian multiplier as what? This one, K, L, is equal to FK, L, this is the production, plus M minus K minus what? PL. So this is the what? This is the production, this is the Lagrangian multiplier. And we have combined the production and the production what? Function and the objective what? Function. So the second step involves what? Taking the first order partial derivative, okay? And then set the results to stationary. And by setting the result to stationary means what? Equating the results to what? To 0. Equating the results to 0. Equating the results to 0. So what do? We take the first order. So we take the first order. This is what I'll do. Take the first order partial derivative, which means that we are going to differentiate. We take the first order partial derivatives. And how do we do it? Remember, it's going to be what? Delta G all over what? Delta K, which is for the capital. Here will give us what? Delta F K L all over delta what? L. Is that not it? Delta K.
Please, we
all
can
over
hear.
delta K. Can you hear me now? Can you hear me? Class, can you hear me? So here we are just differentiating the production. Remember, we are differentiating this
Doc,
particular
we can
function.
hear.
Hello, we
You
can
can-
hear who? Maybe it's your device, but we can hear.
Okay, so here we are just differentiating the Lagrange function. Okay,
our screen is off. You rectify it.
we are just differentiating the Lagrange function, okay, with respect to each. Remember, we want to maximize output, subject to what? To a budget constraint. So now the key thing that we are solving is what? We want to know how many capital should we employ and how many labor should we employ, given our budget, to be able to maximize what? Output. That is what we are looking at. Because I have my money that I want to use to employ this number of people, to buy this number of capital, to be able to maximize what? Output. But I have limited budget. So how many units of capital should I buy? And how many units of what labor should I employ to be able to maximize what? Output, given my limited budget? That is what we are basically solving. So we are solving for what? The number of K, which is the capital, and the number of what? L. So to do that, you need to use the Lagrange function by taking the steps that we are going through. So first, we need to look at how many, what will be the change in what? In G, the Lagrange function, as a result of changes in what? In K. And that is what we are basically doing. So here is the change, that is the D. We are using delta here because we are taking the partial what? Derivative. And we have more than one unit, which is, we have got capital and labor. So if it is capital and labor, we don't use D. Please note, we don't use what? D. We use what? D. Yes. Can you hear me?
Yes, please
We use D if the independent variables are, if you have only one independent variable. And if you have more than one, you use what? Delta. In this case, we have a number of them, okay, which is what? Capital. We also have labor, and we also have what? The Lagrange function. Here, this one is called delta. This is called delta. This one is called delta. So let's make progress. So we are just differentiating output production function with respect to what? Capital. Please note, with respect to what? Capital. With respect to capital. Here would be plus. In this case, remember, we are going to differentiate this with respect to what? Capital. So where here will be 0, as we saw previous differentiating a constant, here will be 0. And here, remember, this is price of capital. Remember, this is raised to the power 1. So here will be what? This one will come here, okay? We have, remember, this is multiplying by M. It's also multiplying by what? By this. It's also multiplying by what? By this. So this delta will be there throughout. So we will have this particular delta here. Because we are differentiating, here will be -1. Remember, this one will come here. And we still have what? Our PK. Remember, this particular K is raised to the power 1 minus 1. Is that not it? So any number raised to the power 1 is what? Here, this -1 will be 0. So any number raised to the power 0 is what? Is 1. So the entire thing will be what? Will be 1. And because of this negative sign, here would also be what? Here would also be negative. Here would also be negative. So in this case, our delta G all over delta K would be equal to what? Just the same thing, which is the production function, all over K, okay? Minus this one, price of what? Price of K, which is the price of capital. So we can call this equation 1. And we do the same thing for what? For labor. We do the same thing for what? For labor. And by doing the same thing for labor, we will also take the derivative here with respect to L, which is labor. So we are going to have what? For labor, we are going to have what? Delta what? G all over delta what? L. It's equal to this one,
delta
FL,
F
all over delta what? L. Is that not it? Minus. Here
delta
would be what?
L.
Here will be delta. Here will be delta PL.
Oh,
This will be equation 2. This will be equation 2. Now let's look at the last one, which is the what? The last one, which is the delta. So we are going to have what? Delta G all over delta. Delta is equal to, here would be what?
delta
Here,
F.
we don't have delta here. So this whole thing will be 0. We only have delta here. And delta, G over delta would be this whole thing, which is the budget what function. Remember here would be 1, 1, 1, 1, 1, 1. So delta G all over delta is the same thing as what? The budget constraint. PK K minus what? PLL. This would be equation what? This would be equation 3. This will be equation 3. Remember, we have done the what? The first order partial derivatives. The second function, the second condition is telling us to do what? To set the results to what? To stationary. So we are going to set the results to stationary, which means that we are going to equate. We set equation 1 to equation 3 to stationary. Which means that we are going to set, which means that we are going to equate. Which means that we are going to equate equation 1 to equation 3 to what? To 0. Are we together? And equation 1 is what? Yes, go ahead. Go ahead. I can't hear you. Is someone asking a question? Okay. So equation 1 is this one is equal to 0. Equation 2 would also be what? This one,
L.
L is equal to 0. And then the
0.
last equation will be what? Equation
Delta.
G, delta J over this one will be equal to what? 0. So this is the second step. This is the second step. This is the second step. So we can set them to 0. So here we are going to set this to 0. We are going to set this one to 0. And we will also set this one to what? To 0. We will also set this one to 0. Okay. We'll also set this one to 0. Now, the final thing that you will do, you will realize that under step 3, here equation 1, here equation 2, here equation 3, it gives you the simultaneous equation. It gives you simultaneous equation. So you have to solve equation, this one. So let's say equation 1 to 3 gives you simultaneous equation. Please note, it gives you the simultaneous equation. It gives you simultaneous equation. So what do? You solve simultaneously. You solve simultaneously for the 3 unknowns. You solve simultaneously. For the what? For the 3 unknowns. For the 3 unknowns or for the 3 variables. And what are the 3 variables? Capital, labor, and then what? And delta. So once you solve, you will get values for what? You will get values for, once you solve, you will get values for what? For capital. You would also get values for what? For labor. You would also get values for what? For lambda. Or the lambda, yeah, the lambda that you will use to do what? To know how many quantities of capital should we employ and how many quantities of labor should we employ. Are we together? So these are the steps that you will need to follow. In fact, based on steps 2, we can do some few things. Remember, this is what? Who can tell me this is what? This is what? you will realize that this is the marginal what product of what capital. This is the marginal product of what of labor. Now let's take this question. Let's solve this question. Let's look at this question. Let's look at this question. Let's look at this question. Now I give you, given a typical Cobb-Douglas production function, given a Cobb-Douglas production function, given a Cobb-Douglas production function, okay, and a budget constraint, given a typical production function and a budget what constraint, show that, okay, show that the product of the ratios, of the input elasticities, show that the product of the ratios of the input elasticities and that of the what, and that of the production input, and that of the production input is unit, okay, if the input prices are homogeneous. How will you solve this? Now, what is the question saying? Given a Cobb-Douglas production function and a budget constraint, maybe of a firm, we're asked to show that the product, and you know product, that is multiplication, the product of the ratios of the input elasticities, okay, and you know the input elasticities, the alpha and the beta from what the Cobb-Douglas production function, show that the product of the input elasticities and that of the production input is units, and you know what unit means. One, if the input prices are homogeneous, and you know what homogeneous means. Last week or two we did it. Homogeneous means the same. So now, how do we solve this? We have a Cobb-Douglas production function. A typical Cobb-Douglas production function. And a typical Cobb-Douglas production function is what? It's what is the name? Q, alpha, L, beta. This is the typical production function. And they are saying the firm, given a typical Cobb-Douglas production function and a budget was constrained. So what is a budget constraint? We just did it. A budget constraint function is what? Remember we said it's M PKK, okay, which is the price of capital plus price of labor. This is it. We should show that the product of the ratios of the inputs elasticities, which means that the ratios of what? Input elasticities, and we know the input elasticities, this alpha and beta, okay, and that of the production inputs. And what are the production inputs? Capital and then what? Labor. They are saying we should show that the multiplication of what? The ratios of the input elasticities and that of the production input is 1. It's units, which means it's 1 if the input prices. And what are the input prices? PK and LK. If the input prices are what? Are homogeneous, which means if the input prices are what? Are the same. So how do we solve this? Please note that this is a Lagrangian function. So what do? We have to maximize. Our what? Our objective function. Please note, and we know the objective function, which is this one. Subjects, we have to maximize our objective function okay, subject to the budget constraint function. So BC is budget constraint function, subject to the budget constraint function. So here we need to do what? To set up, please note, we need to set up the Lagrange function. We need to set up the Lagrange function or the Lagrange multiplier. And how do we set up? Remember from the first step one is to set up the Lagrange function. And we set it up by saying, Gene, there are three unknowns, K, L, alpha, which is equal to what? The objective function, which is here. Is that not it? Our objective function is what? A, K, alpha, L, beta. Is that not it? Which is here. Subject to the budget constraint. So plus this one, M minus what? Minus, that is it. So this is the first step. So this is step one. This is step one. So step two is what? Step two. Step two is for us to take the first order partial derivatives. Take the first order partial what? Take the first order partial derivatives and set the results to zero. And set the results to what? To zero. So we need to differentiate this with respect to each of the unknowns. So first, beginning with what? Beginning with what? Capital. So here will be what? Delta G all over delta K. Here will be what? We are differentiating this and this ones. This is K. So here will come here. So here will be what? Alpha A, K, alpha minus 1, L, beta. Is that not it? Here will be what? Minus. Remember we did this one. Here would remain. Here would be remain. Remember we are differentiating with respect to capital. So here is raised to the power 1 minus 1. Here will be 0. Any number raised to the power 0 is 1. So here will be what? PK. Remember, this is the differential, and then we set it to 0. So we equate this one to 0. In fact, before we even do the second one, which is the labor, we can still break this down as what? As alpha, AK, alpha, this one. Remember, here is minus 1. So we can divide here by what? By K. If you are setting this to 0, it means this one is the same thing. This one, we can let it cross. So when it crosses, it becomes what? Positive. Price of what? Price of K. What can you also find here? From here, you will see that Q is the same thing as what? AK alpha L beta. Is that not it? So which means in place of this one, we can put Q there. We can put Q. And this would simply just mean we are still having our this one is equal to alpha. Is that not it? Q all over what? K is equal to this one. This is the same thing as what? Equation 1. This is the same thing as what? Equation 1. Where is it? Yeah, this is the same thing as equation 1. This is the same thing as what? Equation 1. Now let's proceed. What about the second one? The second one, we are going to differentiate with respect to what? Labor. To know. So here would be what? Here. Where is it? Here. Would be what? Beta. So this will come here. The beta will come here. So we will have beta AK alpha L beta minus what? 1 minus. Here is the same. So here will be minus. So we are focusing on here. This is raised to the power 1 minus 1. So here will be 0. So it's the same thing as PL, L raised to the power 0. Any number raised to the power 0 is 1. So here will be what? PL times this lambda. Okay. So we will have lambda, okay, PL. Remember, we are equating it to 0. So here, the same thing, we can break this down, which will mean that our beta, which is the input elasticity for what? For labor, alpha, beta minus 1, this one, okay. Remember, this whole thing would be divided by what? L, because of this minus. We did this some time ago. Here, this one can also cross to become positive. So here will be equal to what? PL. Remember, this whole thing is the same thing as what? Q. Remember, it's the same thing as your what? Your production. So we can equally have what? Beta Q all over what? L, which is the same thing as what? Which is equal to P what? L. Here is equation 2. Here is equation 2. And you realize that this whole thing is the marginal product of labor. This whole thing is the marginal product of what? Of labor. Is the marginal product of labor. Okay. So what is the last one? So the last one will be what? To look at the lambda, which is what? Delta G all over delta lambda. And delta G all over delta lambda, please note, is the same thing as what? As the budget function. It's the same thing as the budget function. So it will be M. It will be M minus what? PK, K minus what? PL, L. So here again, we can equate this to 0. Here will be equation 3. So we have equation 1, equation 2, and then equation what? And then equation 3. So we can solve them simultaneously. And here, please note, step 3. Step 3, we solve them simultaneously. Solve simultaneously. And to solve simultaneously, you will realize that we have what? Lambda in equation 1. We also have lambda in equation 2. And the two must be the same. We have lambda in equation 1 and then lambda in equation 2. And the two must be the same. The two lambdas must be the same. So here, what can we do? We equate. We make the lambda, we can just divide from equation 2. Where is it? From equation 1 and equation 2, we can make lambda the subject and do what? And equate them. Or we just divide equation 1 by equation 2, and then lambda will cancel out. And that will be the simplest way to do. So equation 1, in this case, let's just, we solve simultaneously. So we can divide equation, what? 1 by equation 2. We can divide equation 1 by equation 2. And what is equation 1? This is equation 1. This is equation 1. Equation 1 is alpha Q all over L is equal to lambda PK. This is equation 1. And equation 2 is beta QL all is equal to, this is beta QL is equal to this one. This is equation 2. So let's divide equation 1 by equation what? 2. We can divide equation 1 by equation what? By equation 2. We can divide equation 1 by equation what? 2. So here we are going to have what? Divide equation 1 by equation 2. So we will have, we will have alpha. This one, is that not it? This divided by this, and this divided by this. We will have this divided by this. So this is the first one, divided by, beta Q all over what? L is equal to this divided by this. So this divided by this will be this one, P what? K all over this one, P what? L. Once we divide, this will cancel this. In this particular case, for the left-hand side, we will have alpha Q all over K times alpha Q all over K times, it will take the reverse. Beta Q is equal to P K all over P what? PL. Remember, we have Q here, we have Q here, so they will cancel out. They will cancel out. So we are going to have alpha all over K dot, which means times L all over what? Beta, which is the same thing as what? PK all over what? PL. Here we can group like terms. So when you group like terms, you will have what? So let's say group like terms. When you group like terms, what will you have? Remember, we have what? Alpha here, all over beta. Grouping like terms means bringing the input elasticities on one side and the inputs on the other side. Dot L all over what? Over K, which is the same thing as what? PK all over what? PL. This is the same thing as alpha all over beta, labor all over what? Capital. It's the same thing as what? Price of capital all over price of what? Labor. Now, what is the question saying? The question is saying that we should show that the product of the ratios of the input elasticities and that of what? The production input means that the ratio of the input elasticities alpha over beta, okay, times input elasticity, which means that capital over labor or labor of the or over capital is units, which means it's 1. If the input prices, and what are the input prices? PK and then P what? L. If the input prices are homogeneous, and it is homogeneous if they are the same. So you realize that here we have what? Ratio of the product of what? As you can see, input elasticities. This is capital, this is what? Labor. And the ratio of the input is the same thing as PK, which is the price of capital over price of what? Labor. So the question is saying that price of what? Capital and price of labor are homogeneous. If price of capital and price of labor are homogeneous, it means that how much you pay for what? Capital, the price of capital is the same as the price of what? Labor. So if the two are the same, it means from this particular equation, we are going to have what? Alpha all over beta, capital all over labor would be equal to, if this and this are the same, which means it will be equal to what? 1. And 1 is what? Units. And that is what we have shown. So if this comes in an exam, this is your final answer. Which means that the elasticities, okay, the ratios of the elasticity of what? Capital and then labor, okay, times labor over capital is 1 if you are paying the same for the production inputs. Are we together or we are not together? Are we together? Okay, now let's look at this and let's solve another question. Is the screen back? Okay, let me see. Let's solve another question. Let's solve another question. Let's solve. Let me give you there was a past question. Okay. There was a okay. Now let's solve this question. Can you see it? This is last year's past question. Okay. So now let's look at this question together. Now the question is what? It's on production function. And it's saying that Overby is one of the leading producers of surface water. Let me allow you to read it so that I'll just give me a few minutes. So you read it and I'll come back shortly.
Where is you? Where is you?
Okay, I'm back. So let's look at this question. It's saying Overby is one of the leading producers of sachet water in Tamale with the brand name Falco. Residents have given good testimonies of the pure water. So Overby is selling pure water. And as such, there has been a surge in the demand for Falco, which is the brand name for the sachet water, because of its quality. Overby is thinking, so here I'm doing my marketing. So start buying Falco. Falco, you always find Falco in Tamale. It's a pure water brand. So it's one of the leading purest sachet water you can find in Tamale. So I encourage you to be buying Falco pure water. Okay. So here, Overby is thinking of expanding the production to meet the rising demand. So he acquired, that is the CEO. So he acquired a new factory, what is the name? A new factory, and estimated his production function as. So you can see the production function is given as Q is equal to 4KL plus what? L raised to the power 2. Overby has set aside a total of 105 Ghana cedis to be exclusively spent on the two inputs. And what are the two inputs? Capital and labor, with the respective unit cost of capital and labor being 1 cedi and 2 cedis. So which means that the cost of capital is what, or the price of capital is what, 1 cedi, and the price of labor is what, is 2 cedis. Using the information above, answer the following questions. 1, specify Overby's what, budget function. 2, how many units of capital and labor should he use to be able to maximize the production what? To be able to produce the maximum output. Show that the ratio of the marginal product to price is homogeneous for both inputs at the optimum. Overby will cease to operate under a certain critical circumstances. At what point would you advise the firm to shut down its operation? Okay, now we are going to do Roman number 1, Roman number 2, Roman number 3. For Roman number 4, we are yet to do it. It's under market structures. Now, with this particular, our question, I hope you have written it. Just write the production function. Q is equal to 4KL. Q is equal to 4KL. Let me see, where is it? 4KL. Have you written it so that I would change the screen? 4KL plus what? 4AKQL. Okay. So another question. So they are saying Overby's production function Over B's production function is what? From the question is Q is equal to what? 4KL. Is that not it? Plus what? L squared. And over B is constrained by what? By budget. How much is over B spending? Over B is M. And they are saying the price of what? Capital is how much? 1 cedi. Is that not it? And price of labor is what? Is 2 cedis. And over B has amount of what? 105 Ghana cedis to spend on what? To spend on the two inputs, as you can find in the question. So here the first question is what? A, or Roman number one. Roman number one. Set up what is over B's what? Budget constraint function. What is over B's budget constraint function? And we know the budget constraint function, is what? M is equal to what? Price of capital times capital plus price of labor times what? Labor. This is the budget constraint function. But from the question, M is what? 105. So we will have what? And this one, you can simply also just rewrite this one as what? Price of K plus this one, L is equal to M. So over B, price of capital is what? Remember from the question, price of capital is 1. So we will have 1 times what? K plus 2, which is the price of labor, times what? Labor is equal to 105. And this is the same thing as what? K plus what? 2L is equal to 105. So this is the budget constraint function. So but in that exam, you don't need to waste your time to do this. You will not even have time, okay, to do that. So if you know the budget constraint function, you can just go ahead and write it. This is the budget constraint function. This is the budget constraint function, and you will get 1 mark. You get 1 mark. So what is the second question saying? What is the second question saying? The second question is saying we should do what? Let me bring it. The second question is asking us that. So here, clearly specify overbid budget constraint function. That is what we have done. The second one is saying how many units of capital and labor should he use to be able to produce the maximum what output? Which means that we need to find, given his budget constraint, we need to find the capital, the units of capital overbid should employ, and the number of labor they should also employ to be able to maximize what? This production function that we have above. So to be able to solve for the number of units of capital and labor, you need to use the Lagrangian function, or you need to use the Lagrangian multiplier, which will give you the ability to know the maximum output overbid can produce, given his budget of 105 and the unit prices of the what? Of the input what? Prices, okay? Of the inputs, capital and then what? And labor. So we go through the 3 steps. 1 is to produce the Lagrange function. 2 is to take the partial derivatives and set everything to 0. 3 is to solve them simultaneously. Okay, now let's proceed. So let's look at the second part. So the second part is talking about what? Values is talking about units. Units of what? Capital and then labor. So in this particular case, we are going to use what? The Lagrangian function, using Lagrange function. Use the Lagrange multiplier. Using the Lagrange multiplier. So step one, we need to set up the Lagrange multiplier. We need to set up the Lagrange what? Function. And how do we set the Lagrange function? We have the what? The objective. So in this case, you will realize that this is our what? Our objective function. This is our objective function. This is our objective function, which is the production function, and the budget line. and this will be our what? Our budget constraint function. And this will be our budget constraint function. So we have to combine the objective function, which is the production function, and the budget constraint function to be able to know the Lagrange multiplier. So let's set it up. So in this case, we are going to have what? First step, this one, we have what? 3 unknowns. This and this is equal to the production function. Remember, we said it is 4KL, 4KL, plus plus and can you mute? Can you mute? Can someone mute the person? So here we have our what? Our budget constraint function. And remember, our budget constraint function is this one. So please note how we are doing it. So it is 105. I don't know why I can't write 5 properly. 105 minus what? K minus what? 2L minus 2L. So this is the Lagrange multiplier that we have what? We have set up. So step 2. Step 2. Let me mute the person. Step 2. So step 2 will be to do what? To take step 2. We take the first order partial what? Derivatives. We take the first order partial derivatives of what? Of this one. And do what? And set the results to what? To stationary. And set the result to stationary. And set the result to stationary, or and set the result to 0. So how do we do it? So first, beginning with what? Capital. We are going to have what? Delta G all over delta K. Here will be what? If you differentiate this with respect to K, which is capital, we will be left with what? 4L, because here will be raised to the power 1. Here is also raised to the power 1. Here, we bring that 1 here, times 4, A raised to the power 1 minus 1, which will be 0. So this entire thing will be 1, okay? Which is here. Here will be 1, because any number raised to the power 0 is what? Is 1. So we are going to have what? 4L. 4L. Plus, do we have K here? No. So here will not be there. Here, what are we going to have? We have what? Delta. But here is what? Here will be minus 1. This is 1 minus this. So any number raised to the power 0 is what? Is 1. So this delta applies to all. Remember, if you open this up, it's going to be 105 delta minus delta K minus what? 2L delta. If you open this up like this, this is what you will get, 4KL. If you open this up, this is what you will get. So we are literally just differentiating this. So we are differentiating with respect to capital. Here we don't have K here, but we have K here. So it will be minus what? It will be minus what? 1. It will be minus 1, as you can see. And that 1 here will be times what? The lambda. So here would be lambda. Is equal to 0. The second one is to do what? Is to differentiate with respect to what? Labor. And once you differentiate with respect to labor, what will you have? Let me cancel this ones. So here will be what? 4K. Remember, here will be 4K because here is minus 1 and the rest. So 4K. So here will be 4K minus. Here we have L, so it will be plus. This 2 will come here. So it will be 2 minus 1. So 2L minus 1 Okay, so here 2 minus 1, it will be what? 1. So this will stay here. It's left with this particular side. Here will be what? Minus 2 lambda, as you can see here, minus 2 lambda, because this L will go, leaving minus what? 2. So here we minus 2 what? Minus 2 lambda is equal to 0. And then the last part will be what? Delta G all over delta lambda would be what? 105. Remember I said it's the same thing as what? The budget constraint function, which is here, which is the same as here. Minus 2L is equal to 0. So here would be equation 1. Here would be equation 2. Here would be equation what? Would be equation 3. Here would be equation 3. Here would be equation 3. Okay. So now we will solve this simultaneously. We will solve this simultaneously. So how do we solve this simultaneously? You can see that from equation 1 and 2, we have what? Lambda, we have lambda here. So we can make lambda the subject in equation what? 1 and 2 and equate them. We can make lambda the subject in equation 1 and equation 2 and equate them. So here, step 3. Step 3. Step 3. So we can make lambda the subject. We are solving it simultaneously, okay? So let me just do it this way. Solve simultaneously by making lambda the subject in what? In equation 1 and 2, and then equating the 2 and equating the 2. So this is equation 1 and this is equation 2. So remember, from equation 1, if you make lambda the subject, it simply means sending this one to cross. So from equation 1, we have this all over this 4L minus what? Lambda is equal to 0. So if you want to make lambda the subject in equation 1, it simply means lambda is the same thing as what? As 4L, as you can see. Lambda is the same thing as what? As 4L. And equation 2, we have this one. And what is equation 2? Is this one. 4K plus 2L minus 2 lambda is equal to 0. So let's make lambda the subject. In this case, this one can just cross. So if it crosses, it will be 4K plus 2L is equal to what? 2 lambda. We can divide here by 2, divide here by 2, divide here by 2. This will cancel this. This will cancel this. So what are we going to get? We are going to get 2K plus what? L is equal to lambda, is equal to lambda, is equal to lambda. So we can say this is equation 4. This will be equation what? 5. So now we then equate equation 4 and equation 5. Equate equation 4 and equation what? 5. Equation 4 and 5. So how do we equate them? We have equation 4 here, as you can see, and we have equation 5 here. So which means we are going to have 2K plus what? L is equal to 4 what? 4L is equal to 4L. Is equal to 4L. So when you do that, we are going to have 2k plus L minus, let's group like terms, 4L is equal to what? 0. So here will be 2k minus what? 3L is equal to 0. Here can be equation 6. So you can see that we have reduced it to 2 equations. We have this particular equation and the budget constraint equation. Where is it? And the budget constraint equation. So we are now going to combine equation 3 and equation what? And equation 6 to solve it. We are going to combine equation 3, and then what? 6, or using equation 3 and equation 6. And equation 3 is the same thing as what? Equation 3 is the same thing as what? Our budget constraint function, which is here. 1, 0, 5 minus what? K minus what? 2L is equal to 0. This is equation 3. And equation 5 will be what? Will be this one. Equation 5 will be this one. Okay, will be this one. So if we want to use it to solve it, remember, this particular equation, which is 5, is the same thing as what? K plus what? 2L is equal to 105. This is the same thing as equation 6. So we will use this equation and this equation to solve. We will use this equation. This is the same thing as equation 3 rather. This is the same thing as equation 3. So let's use it to solve simultaneously. So let me just rewrite it so that we can see clearly. So we have 2k minus 3L is equal to 0. And then the last one will be what? K plus 2L is equal to 105. So how do we solve this? Let's say equation 3. This is equation 6. This is equation 6. And this is equation 3. So how do we solve this simultaneously? So let's use elimination method. So using elimination method, we multiply. We have to eliminate 1. So it will be easier if we eliminate what? L, because here is positive and here is what? Is negative. So that when we add, it will go. We will eliminate what? L, which is the labor. So we multiply each by the coefficient by the coefficient of the other equation. So if from equation 6, we will multiply by the coefficient from equation what? 3. So we will pick this and multiply by 2, and then multiply here by what? By 3. Multiply here by 3, and multiply here by 2. So here will give us what? 4k, is that not it? Minus 6L is equal to 0. And here will give us what? 3k plus what? 6L is equal to, so 105 times 3. We will get 315. 315. So here will now be equation what? Maybe let's say equation 7, equation what? 8. So add equation 7 and 8. So when you add this plus this, what will you get? 7k. This plus this will be 0. So 7k will be equal to this plus this. Here will be 315. 315. So we divide here by 7, divide here by 7. So when you divide by 7, k would be equal to what? K would be equal to what? 45. K would be equal to 45. K would be equal to 45, which means that over B as a company should employ 45 units of what? Of capital. So what about labor? What about labor? So we can put this into the budget function. Remember, anywhere here we can solve for what? For labor. We can solve for labor. So we can put it in the what? In the budget function to solve for what? For labor. Now that we have capital. So let's put, so to solve for what? For capital, to solve for labor, we put K, which is given as 45, into the what? Into the budget constraint function. Into the budget constraint function. And the budget constraint function is what? K plus 2 what? L is equal to 105. But K is what? It's 45. So we are going to have 45 plus what? 2L is equal to 105. So here will be 2L is equal to 105 minus what? 45. So 105 minus 45, we are going to get 60. 2L, divide both sides by what? 2, divide both sides by 2. This will cancel this. So labor would be 30. Labor would be 30. Which means that the firm must employ 30 units of what? Labor, and then 45 units of what? Capital, to be able to maximize what? The output. To be able to maximize what? The output. So now what is the output? So what is the output that the firm can maximize with this? So we now have to put K as what? 45 and L as what? 30. Remember, we are putting it into the what? Into the production function. Or we are putting it into the objective function. Into the production function or the objective function. And our production function, we said is this one, 4KL plus L what? Square. And we know L, we know K. So here, the maximum output OverB can produce, okay? That's the maximum number of pure water sachets or bags OverB can produce will be what? 4, 45, 30 plus what? 30 raised to the power 2. So this whole thing, what will you get? 4 times 45 times 30. We are going to have 5,400 plus 30 square. You will get 30 square, you will get 900. So this will give you 6,300. So OverB can produce 6,300 units of what? Of bags of pure water if he employs 45 units of capital and only 30 units of what? Labor. This is the maximum output that OverB can produce, given OverB's budget constraint of what? 105 Ghana cedis, given OverB's budget constraint of 105 Ghana cedis. Now, what about the lambda? What about the lambda? What about the lambda? What is the mean of the lambda? You will realize that where can we find the lambda in this equation? Where can we find lambda? We can find lambda here. In fact, we can also find it here. You will realize that lambda is the same thing as what? 4L. Lambda is the same thing as what? 4L. So lambda is the same thing as what? 4L. Lambda is the same thing as what? 4L. Which means that lambda is the same thing as 4 times L. What is L? L is 30. L is 30. Which means lambda is the same thing as 102. Which means that if OverB's budget constraint, okay, changes by 1, if OverB's budget constraint changes by one cedi, remember we have 105 cedis as the current budget constraint, giving us a lambda of what? 120. Now, if OverB's budget constraint increases by 1 cedi, which means if it moves from 105 to 106 cedis, the production this production will increase by 120, by 120. So the economic meaning of lambda, is what? If the budget constraints, okay? If the budget constraint, okay, let's say if a firm's budget increases by 1, okay, or by unit, production will change, or production will also increase by the value of lambda, by the value of what? Of lambda. So in this case, if Overby's budget increases by 1 cedi, moving it from 5 Ghana cedis to 106 Ghana cedis, Overby's production, okay, will increase by 120 Ghana cedis. So the new Overby's production units will be the 6,300 plus 120, which will give us what? 6,420. If Overby is now increasing the budget to 106. Remember, there are 2 ways to solve this. That is, your new budget function will now be what? Instead of using 105, your new budget function will be 106, which is equal to price of capital will still remain the same. 1 plus 2 what? L. K plus 2L as the budget constraint function. And you have to use this to solve all of this again. But this is going to be a tedious task. So the lambda gives you a shortcut to estimating the unit changes in the production input as a result of changes in your budget constraint. So which means the economic meaning of the lambda is literally talking about what? The extra production that you are going to get, okay, when you increase your budget allocated for a particular combination of what? Inputs, or when you increase the allocation that you want to spend on the production input, your production or output will change by the value of what? By the value of lambda. Any question? So which means that in this case, therefore, for Overby to maximize outputs, okay, Overby need to employ 45 units of what? 45 units of capital, and how many units of labor? And 30 units of what? Of labor. 30 units of labor. Now let's look at the last part. The last part is saying we should do what? The last part is saying we should do what? The last part is saying we should show that the ratio of the marginal product to price is homogeneous for both inputs. Is homogeneous for both inputs at the maximum, which means that we should show that the marginal product, the ratio of the marginal product to price, which means that the marginal product divided by price is the same for both inputs. As you can see, MPK all over price of K is equal to MPL all over the price of what? L, which means that the marginal product per CD, okay, is the same for each production input. So how do we solve it? They are saying we should show that. That is the third part. We should show that the marginal product of capital all over the price of capital is the same as the marginal product of what? Labor all over the price of what? Labor. Which means from the production function, we need to calculate the marginal product of what? Capital. And we also need to calculate for the marginal product of what? Labor. Now, when you pick the production function, remember our production function, we had it as Q is equal to 4KL plus L squared. So in this case, our marginal product of capital, remember, is the same thing as what? Delta Q all over delta what? K. And delta Q all over delta K will be what? 4 what? 4L. Will be 4L. Is that not it? It will be 4L. 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 This k will go because it's raised to the power 1 minus 1. So here will be 0. So this literally means 4k raised to the power 0, L. Any number raised to the power 0 is what? Is 1. So it will be 4, 1, L, which means 4 times 1 times L, which is this one, which is this one. But we know that L is what? 45. But we know that L is 45. But we know L is 30 from the question. L is 30. The one that we found, L is 30. So the marginal products, okay, the marginal product of capital would be what? 4 times what? 30, which will give us 120. What about the marginal product of labor? The marginal product of labor is the same thing as what? Delta Q all over delta L, which is, as you can see here, 4K plus this 2 will come here. L, 2 minus 1. So here will be 2L1, which is the same thing as what? 2L. Any number raised to the power 1 is that number, but any number raised to the power 0 is 1. So here will be what? 2L plus what? 2L. But K is what? 45, L is 30. So here the marginal product of labor will be 4, 45 plus 2, 30. So what will you get? 4 times 45. 4 times 45, you will get 180 plus 2 times what? 30, you will get 60. So 180 plus 60, you will get 240. This is the marginal product of what? Of labor. But the question is saying that we should show that the marginal product of capital to price of capital is the same as the marginal product of labor to price of what? Labor. So which means we are going to show that the marginal product of capital all over price of capital is the same as the marginal product, of labor to price of what? Labor. Now, marginal product of capital, where is marginal product of capital? We got it as what? 120. We got it as 120. So here will be 120 divided by price of capital. And what is price of capital from the question? Price of capital from the question was 1. Where is it? From the budget constraint, you can even find it here. It's 1. It's 1. And then price of labor is what? Is 2. So price of labor is 2. So here would be divided by what? 1. But let me just put it here. Price of capital is 1 and price of labor is 2. So here would be this divided by 1, which is the same thing as what? What is the marginal product of labor? 240. So marginal product of labor is 240 all over price of labor, and price of labor is 2. So when you divide, you are surely going to have 120, which this divided by this, which is the same as 120. So you have shown it as shown. Are we together? Are we together? Okay. So in the third one, the question is basically talking about at what level should the firm cease production, and we will be talking about it in the subsequent sections and the market theory. Okay. Any question? Any question? Are we together? Can you hear me?
Yes, sir, we can hear you, sir.
Okay. So I want to end what is the name? This particular topic. I want to end this particular topic here. So you should expect some of these things in the exam. Okay. We have a number of them. So you should know how to solve for the constraint optimization. It's basically talking about how much a firm can optimize or maximize its production, okay, when it is limited by a budget. How many capital should it employ and how many units of labor should it also employ to be able to maximize what? Production, to be able to maximize production. So this brings us to the end of this particular topic. Next, we are going to look at what? Cost theory. Is it time? Is it time?
Please, it's time. Yes, please.
Past time.
Okay. So next week we are going to look at cost theory, and I'm going to be very fast. Today you guys spent a lot of my time. I'm not sure whether it's even up to 2 hours. Frank, is it up to 2 hours? Okay. So next topic, we are going to look at what? Theory of cost theory. That is for next week. So next week, remember this week we are looking at what? The production side, and the subsequent week we are going to look at the cost side. Please note, this Lagrange function that we have done we will also be using it in the cost theory, and we will also be using it in the what? In market structures. So please get a full understanding of it. And this will of course definitely be coming in the exams. So please master the Lagrange multipliers and taking the partial, the first order partial conditions and knowing how to solve simultaneously. You can form group studies so that someone can guide you guys. It's actually very simple if you sit down to study it, and you will be seeing this in the exams. You'll be seeing this in the exams. Any question?